I'm just going to talk a bit today about the aims and the purpose of the keloid scarring project. When you speak to patients with keloid scars, they talk about the physical symptoms. This is the pain, sometimes very intense, the itching and the discomfort that comes with a keloid scar. But just as bad as the mental burden of the disease, the loss of self-confidence and the social anxiety that it causes. One of the worst aspects of having keloids is the hopelessness. Keloid scars are rarely cured, and some therapeutic interventions can actually make things worse. But what is a keloid scar? Now, normal scars appear when the wound healing process can't finish the job. You get a cut to the skin, it forms a thick mass of tissue, and that remains pretty static over the rest of your life. With disease scars, with pathological scars, these scars continue to grow. Hypertrophic scars will grow upwards within the original bounds of the wound, and keloid scars will grow both upwards and outwards from that original bound of the wound, and they'll continue to be symptomatic. They'll continue to give you unpleasant symptoms. Now, these types of scars can occur after almost any type of wound to the skin, large or small. They can occur after unrelated surgeries, bug bites, ear piercing vaccinations. Even ingrown hair or an acne scar can cause a keloid, and they can grow to extreme sizes. And when you look at what causes it, it varies across the globe. Your chances of developing one depends on where in the world you're from. So the highest rates are seen among some African groups, as much as 1 in 6, and then South Americans are the next most likely. It's a major problem in the East among Japanese and Chinese populations. And when you look at the UK, we estimate that up to 1 in 300 people in the UK may have a keloid, and actually 4 times this, about 1 in 70 in the US. Now, why are they such a problem? Well, the obvious treatment for a lot of skin conditions would be simple surgical excision, but keloid scars have a nasty habit which makes this a really poor treatment on its own. They recur at a site, and because by removing them you've made a larger wound than was originally there, they'll grow back larger, and they often grow back worse. So this simple fact has had a profound effect on the way keloids are treated, and it's shifted much of the treatment towards management and containment rather than removal and the chance of a cure. These problems create a vicious cycle. Poor treatment options mean that sufferers are an overlooked and neglected group, and the reluctance to attempt removal limits the availability of tissue that we can use for research, primary research. Because of this, keloid scarring is poorly understood disease, and this inhibits in turn the development of new treatments for sufferers. So we looked at this problem and we thought, how can we break this cycle? Well, there's 2 ways we can contribute to this. When Raft surgeons did routine plastic surgery at Mount Vernon back from 1997 to 2003, they had a very good idea, and that was that they were wasting a lot of the material that they were doing with these routine surgeries. So they sought the permission of patients to store it and archive it and create a cell archive from a bunch of different conditions, and they still exist today. Included in that was keloid. So we have a large number of keloid cells from patients sitting in our cell archive. So our first aim would be to use this archive, this time capsule, and develop it into a full-scale cell bank, and to be able to suitable for use for our own scientific research, and also for scientific research of other labs. So this would allow them to study the disease, test new drugs, look for new treatments. But we don't want to just wait for other people to solve this problem. We want to be able to help these patients ourselves. So the second part of this project would really be to develop our own sort of treatment. And when we look over the available options that there is one very clear option that we specialize in that's missing, and that's the biomaterial approach. In the skin, these biomaterials are called dermal scaffolds, and they're already used in all their different types to control the way that a skin wound heals and to avoid scarring, normal scarring. So what we'd like to do is, using our cell bank, our second aim would be to develop a scaffold that specifically targets keloid cells and could reduce the chance of recurrence and offer keloid sufferers the chance of a lasting cure. Thank you very much for your attention.